So in this video we're going to be looking at Ohm's law. Now Ohm's law states that current is directly proportional to the potential difference providing the resistance of the conductor remains constant. So what this means is that if we can keep the resistance in a circuit constant, then the current is directly proportional to the potential difference. So if we increase the potential difference, right? So remember, the potential difference is the change in potential energy per unit charge between 2 points in the circuit. So if we increase the voltage, right, potential difference, then current will increase directly proportional. So as we increase voltage, we increase current. So we increase the energy given to the electrons, the rate at which they flow is going to increase. This is all assuming that resistance is constant. Okay? So if we are to increase current, then that would decrease. If we would increase the resistance in a circuit, then that's going to decrease the current, because we know that resistance is just the opposition to the flow of charge. So what we can come up with from these ideas, we can come up with Ohm's law, where voltage is equal to the product of the current measured in amps and resistance measured in ohms. So this is a really important relationship to know and understand. This is Ohm's law, voltage equal current times resistance. Later on in the prac, we're going to change the voltage, measure the current, and then from that we can actually calculate the resistance in a circuit or in a wire. So, Ohm's law, now resistance is constant for ohmic resistors, which conform to Ohm's law. So, Ohm's law is an approximation only. It's not all things follow this law. It's only valid for certain materials, and these are known as ohmic conductors. And if we were to plot the voltage against the current, right, because this, we could, if we were to replace, and let me put the pen on. Now, if this was our y-axis and this was our x-axis, we could write an equation. So we know that the equation of a straight line is y equals mx plus c. Now our y variable is voltage, our x variable is current, our c is 0 because it goes through the origin, and our m is actually our resistance. Okay, so we can actually find the resistance of an ohmic conductor by calculating the gradient of the line when plotting voltage on the y-axis and current on the x-axis. So later on in a formative prac and in your summative prac, you're going to be changing the voltage, measuring the current using an ammeter, and you're going to be plotting some data. You're going to be drawing a line of best fit and calculating the gradient. And that gradient gives you the resistance of an ohmic conductor. Okay, so the gradient of the line gives you the resistance. Now, I'm not going to get you to do the formative prac now, I'm going to get you to do it on Thursday. So we're going to look at this. So, using V equals IR, so V equals IR is Ohm's law. We can use this to solve for voltage, current or resistance. So you can obviously rearrange it. Okay. Now on your formula sheet, I can't remember if it's in this form or this form, but it's easy to swap between them. If it was given it to you in this form, well then to get voltage you would times both sides by current and you'd get this. Or if you wanted to get current, you could swap the R and the I to get current. Now, in this example, we're going to have a metal conductor has a resistance of 5 ohms. So this is a circuit. This is a power supply of 10 volts. There's a resistor of 5 ohms. What current will flow through the conductor if a potential difference of 10 volts is maintained across it? So, in this problem, we're trying to find the current. So obviously, if we had V equals IR in our formula sheet, to get current by itself we would divide by resistance, so we'd divide both sides by resistance when we get voltage over resistance. Now we know the voltage is 10 volts of potential difference, and our resistance is 5 ohms. So the current simply is 10 divided by 2, which will be 2 amps. Remember, 1 amp is 1 coulomb of charge per 1 second. So I'm not doing many examples. The formulas are pretty easy to use. Now, these questions now sort of mix up everything you need to know. So you need to know potential difference is the amount of change in potential energy per unit of charge, or potential difference is the work done in moving a charge between 2 points in a circuit, so the work done per unit of charge. You also need to know that current is coulomb is the amount of charge per the amount of time passing a point in a circuit, and that's measured in coulombs per second, or amps. And remember, potential difference is measured in volts or in joules per coulomb. Also, you need to know what resistance is. So resistance is the opposition to the flow of charge. The higher resistance, less flow. Lower resistance, higher flow, higher current. You also need to know that resistivity is a property of a material, and it determines how the amount of resistance per unit area per length. So it's resistance A over L. Or have I done that the wrong way around? I always get that the wrong way around. RA over L, good. So RA over L. Or you need to know that resistance is the resistivity times length over A. So you need to know that the resistance of a material or a component is directly proportional to the material it's made out of, the length of the conductor, and it's inversely proportional. So it's directly proportional to the material it's made out of and the length of the material. The longer the material is, the more opportunities for collisions with electrons with the ions, so the electrons get slowed down. And it's inversely proportional to the area. So that means that as you increase the cross-sectional area of a wire, so you make it larger, then there's more opportunities for the electrons to flow through, so less resistance. So these questions are a bit of a review of everything you've done so far in looking at electricity and electrical circuits. Let me know if you have issues with these questions.